This sync session paper addresses the ethical considerations regarding the use of quality software in the manufacturing industry. It examines the industrial process control systems, trade-offs between project schedules, costs, and quality, and software product liability claims. The premise of this research and presentation is derived from George Reynolds' book, Ethics in Information Technology. This is the assigned text for IA0730, Legal and Ethical Practices in Information Security for the University of Fairfax. The research is predicated on 3 questions. These 3 questions are: why must companies place an increased emphasis on the use of high-quality software in business systems, industrial process control systems, and consumer products? What potential ethical issues do software manufacturers face in making trade-offs between project schedules, project costs, and software quality? And what are the 4 most common types of software product liability claims? Business information systems utilize a set of interrelated components. These include hardware, software, databases, networks, people, and procedures. A common type of business system is one that captures and records business transactions. Software is used to control industrial processes to reduce costs, eliminate human error, improve quality, and shorten the time it takes to manufacture products. High-quality software systems are able to perform quickly and efficiently, and are consequently easy to learn and keep system downtime to a minimum. Now that computers and software have become integral parts of almost every business, the demand for high-quality software is increasing. Software defects can cause software systems to fail to meet the needs of their users. Software quality determines how effectively the software will meet the needs of the user. Quality management defines the deliverables for a set of software by defining, measuring, and refining the quality of the development process. Deliverables, including statements of requirements, flowcharts, and user documentation, are among those required. Quality management serves the purpose of helping developers deliver high-quality systems. Even so, first releases rarely meet expectations until they've been used for a while, the problems have been identified, and then corrected or upgraded. If a system has the potential to cause death or injury, then it's deemed to be a safety-critical system. This then requires the flawless performance of software. Building software for safety-critical systems requires professional, formal, and rigorous methods and tools to certify. Without strong measures to identify and remove software errors, disastrous consequences become unavoidable. But even with these type of preparations, the software associated with safety-critical systems can still be vulnerable to errors that can lead to injury or death. When developing safety-critical systems, it's best to assume that safety isn't automatic, regardless of an organization following standards in development methodology. Safety-critical software must go through rigorous, time-consuming development, including requirements definition, systems analysis, design, coding, fault analysis, testing, implementation, and change control. Resultantly, safety-critical system software is more expensive and time-consuming to develop. Software developers must recognize that their software is only one part of a system and that other components typically include human error factors, such as system users or operators, as well as hardware and other equipment. Software developers must ensure that the entire system, not just the software, will operate safely. A safety system engineer is the key to making sure these additional tasks are completed by using a logging and monitoring system to track hazards in the project. This must be used at each stage of the software development process. Safety reviews should be held throughout the development process to track safety matters. The safety engineer needs to understand that their role is to influence the design of the system, ensuring it operates safely. There are ethical dilemmas that arise from the increased time and expense of completing safety-critical software. Companies must carefully weigh these dilemmas to ensure they are developing the safest possible product for their customers. Knowing whether they performed adequate testing is part of this process. and knowing how much testing is enough requires trained, careful decision-making. Safety-critical systems must consider redundancy in their building design. This means that there must be multiple components to perform a single function so that the failures and errors can be overcome. The lack of enough redundant systems can lead to major problems. Reliability is a measure of the rate of failure in a system that would render it unusable over its expected lifetime. The more you add components, the more complex the system becomes. Resultantly, the chance of failure increases. So then, building redundancy into complex and safety-critical systems is a must. An accepted standard for reliability in designing a system is called the 5 nines, represented as 99.999% reliability. What this would mean is that a system would have only 5.26 minutes of total downtime per year. Reliability doesn't necessarily translate to safety, because these are two different system characteristics. Reliability is the capability of the system to continue to perform. Safety is the ability of the system to perform safely. A system can be reliable, but unsafe. Manufacturers, sellers, leasers, and other liability for injuries caused by defective products is defined as product liability. Product liability in the United States is mainly covered by common law and Article 2 of the Uniform Commercial Code, which deals with the sale of goods. If a software defect causes injury or loss, the injured parties may be able to sue. This can be due to physical mishap and death, loss of revenue, or an increase in expenses due to a business disruption. Software product liability claims are typically based on strict liability, negligence, breach of warranty, or misrepresentation. In the following slides, we'll look closely at each of those four. Strict liability means that the defendant is responsible for injuring another person. Plaintiffs need only prove that the software is defective or dangerous and that the defect caused the injury. There is no requirement to prove carelessness or negligence, nor even who caused the defect. All parties in the chain of distribution may be sued. There are statutes of limitations for claims of liability, meaning that suits must be filed within a specified period following the injury. Negligence is failing to do what a reasonable person would do, or doing something that a reasonable person would not do. When sued for negligence, a software supplier is responsible for harmful defects that could have been detected and corrected through reasonable software development practices. Software manufacturers or organizations with software-intensive products must be prepared to defend themselves since they are frequently sued. A warranty assures a certain standard of quality. A warranty of quality may be either expressly stated or implied by law. Express warranties can be oral, written, or inferred from the seller's conduct. Sales contracts contain an implied warranty of merchantability, which requires that the following standards be met. These standards are that the goods must be fit for the ordinary purpose for which they are used. The goods must be adequately contained, packaged, and labeled. The goods must be of an even kind, quality, and quantity within each unit. The goods must conform to any promise or affirmation of fact made on the container or label. The quality of the goods must pass without objection in the trade, and the goods must meet a fair, average, or middle range of quality. If these terms are not met, the buyer can sue for breach of warranty. Ideally, however, most dissatisfied customers will resort to less than litigious options first, such as replacement or refund. Plaintiffs are required to show through a valid contract that the supplier did not fulfill its advertised deliverable in order to win a breach of warranty claim. Because the software supplier writes the warranty, this claim can be extremely difficult to prove. Damages are generally limited to the price paid for the product. Intentional misrepresentation is when a seller misrepresents the quality of a product or conceals a defect. Advertising, salesperson's comments, invoices, and shipping labels are all forms of representation. Limited warranties and disclaimers are often used to avoid claims of misrepresentation. The difference between what you, as a software developer, can do legally, a floor, and what you should do, a ceiling, is often vast, confusing, and not always intuitive. As stated in the introduction, high-quality software systems are easy to learn. It follows that unexpected downtime is also kept to a minimum. With computers and software becoming integral parts of every business, high-quality software is in increasingly high demand. Consumers of these products simply cannot afford system crashes, lost work, lower productivity, or security holes spreading viruses, stealing data, or shutting down their website. A solid, documented, certified software development methodology will define the software development process, the responsibilities for accomplishing objectives, and will recommend specific techniques for accomplishing the objectives. It will also offer guidelines for managing the quality of the products throughout the development cycle. Collectively, this enables manufacturers to produce high-quality software, forecast project completion milestones, and reduce costs to develop and support software. Additionally, this should help protect from legal liability for defective software by reducing the number of software errors that could cause damage, and by making negligence more difficult to prove. Not all companies will adhere to these standards. Companies hungry for profit overlook common ethical business standards. Software developers get involved in unethical practices by putting profit above people's lives and turn away from the consequences. It is the responsibility of software engineers to provide users with a secure and transparent program that they can trust.